Hi, my name is Matt Holliday and welcome back to my Go class. So in this segment, I'm not going to introduce any new material. Instead, what I want to do is go and take one of the exercises out of the Go programming language book, and we're going to work through that with a small modification. Okay, so on this slide, I'm just going to describe what we're going to do. This is exercise 5.5, and the exercise was to get some HTML and look through it for some things. Now, I think the original exercise involved going out on a network socket, and we haven't done that yet. So instead, what I'm going to do is I'm going to copy a snippet of HTML into the program as a raw string, and then we're going to write the code that's actually going to parse that HTML. And that'll be our exercise. And what I want to mention with that is I have the code for this out in a repo. So the repo is under the username mat4biz, M-A-T-T-4-B-I-Z, and it's titled Go Class Exer 5.5. And in there I have the code, the final code for this to run it. And it's also, there's a run on replit button. So you can actually push a button and have this open up a replit and you can run it there. Okay, so we're in the playground. And what I said is I'm going to copy some HTML in here. So I have a little bit in here. It's a raw string. And I just want to point out raw strings have backticks. So it starts up here with this backtick and there. And it can span multiple lines. It can have embedded new lines in it. And whatever's in there is going to be completely not interpreted. So I have some embedded quotation marks in there. That's perfectly fine. They're going to come through as quotation marks. I don't have to escape them. And if I just run this program right now, all it's going to do is just print out that text. Okay, so there's a raw string. I put it in here. And instead of going on the network, like I said, we're going to do one thing different in this exercise. We're just going to work with this text right here. Okay, so now I'm going to start with a slightly different main program. And what I have to do first, we're not actually going to parse the HTML from scratch. We're going to call a library routine for this. Because what we want to do is parse it into some internal form, and then we're going to search the internal form looking for the words and images as the exercise asked us to do. So we're going to go ahead and call a library routine. And the library routine wants something it can read from. And what it really wants is a byte string. And so we're going to take our raw string, we're going to convert it to a sequence of bytes. We're going to create a reader around that so that the HTML parser can treat our reader the same way it would treat, say, a network socket. So it's just a convention. And of course, we're going to have to come up here and we're going to have to put in a few things. Right? So we already know we're using the bytes package, and we'll use FUMP. And we're going to use OS at some point, so I'm just going to go ahead and include that. And strings. And we need one other package. We're using this HTML package, and actually it's sort of a quasi part of the standard library. There's another part of the standard library out here at golong.org, which is called the extension to the standard library. And we're going to go in there and get the net HTML, and that's going to give us our HTML parser. So golang.org/x, when we see that, it tells us, well, there's sort of the standard library, and then there's sort of the extended part of the standard library, or experimental part. Some stuff that's been worked on, and it hasn't completely been folded into the standard library. But here's the thing, you can treat it the same way. So we're just going to treat this HTML parser the same as we would treat any part of the standard library. It's just the path to get it, when we talk about the import path, is different. And this brings me to a topic that I haven't really talked about. When we start using third parties, and we'll see more of this, instead of just giving the name of the package, we're going to give an import path. In this case, it's golang.org. In some cases, it'll come from GitHub. And in fact, in many cases, we'll go and say, hey, go to GitHub and get this package. And later on, when I talk about building in modules at the end of the course, I'll talk a little bit about how that actually happens. So now we've come back to the main body of the program. We've parsed the text into some sort of internal HTML structure, a document structure. And of course, the first thing we've got to do is ask, did that work? And if it didn't, we'll use our usual technique of printing an error and stopping. And we'll just say parse failed, %s, and all right. So we won't just print the error, we'll print a little piece in front of it that says, hey, the parse failed. But when that happens, right now we're just going to say we're done because I don't know what else to do. So once we've done that, we have something we can go look at. And what we want to do is we want to fill in two variables with something. And the something, the point of this exercise was to actually write a function, which I'm going to give it a very wordy name. I think that's what it had in the text. All right, count words and images. And the result of that, we're just going to print out. So we're kind of taking a top-down approach to this. All right, I've got my document, I've parsed it. I'm going to write this function, count words and images. It's going to come back with a couple numbers, and then we're just going to print them out. Okay, of course, that's not going to work. If I run it, it's going to tell me, well, okay, so first of all, it didn't like, oh, never mind. It told me it actually had to download the third-party package. So the stuff at golang.org/x, even though we can think of it like part of the standard library, it actually, the Go went out and got that and brought it down for us from golang.org and made it part of the program. So that part is not an error message. I didn't use strings yet. That's a problem. And I didn't actually write the count words and images. That's a problem. So that's what we need to do next. That's really the exercise we've got to do. So count words and images is going to be a function. And it's going to take into it the results of calling html.parse. Now, I don't have godoc built in here, but html.parse is going to return some internal structure. And that internal structure is a tree structure because that's how HTML works. If we look at this, you know, we have an HTML thing and then within that's a body and then there's some other stuff, but it's really a tree structure with children under various nodes. And because of that, it's going to give us basically a pointer to the head node, which may in turn have children under it. Okay? And of course, we're going to return two integers. We are not going to return any error out of here right now. Okay? We're going to assume that if we parsed it, we've got some tree, and the tree may be empty or the tree may have nothing in it, but that's not really an error. We'll count what we can count and move on. So I'm not going to worry right now about returning errors. What I do need to do is I need to create, all right. Okay, that's fine so far. So count words and images returns something, right? And I've got to actually do some work. Now, the reason I have this little function here is because given the doc is a tree structure, I'm going to go and do a recursive function. So I sort of need a landing spot, and this is it. I'm going to start with count words of images. I'm going to define these two variables, and then what I'm going to do is recursively add up by calling some function visit that's going to visit all these nodes. And so it starts visiting the top node. All right. And that may be recursive, and when we're done, it will have filled in as many words and pics as it can, so it's going to add them up. So we're going to have, the reason we have this one function, count words and images, is to establish a place for these two variables that we are going to pass in by address. So we're going to pass in pointers to words and pics so that they can be modified as we go. And when we're done with this visit, it will have visited some number of nodes, it will keep adding into those two variables, and then we just return them, and we're done. So really all the work is actually the visit function. Okay, so again, main is going to call this landing function. The landing function is going to set up these two variables to count for us, and then we're going to do func visit. Okay, so func visit is really the interesting part of this program. And what it needs is it needs a node, all right, as a starting point. Now, so here's the thing about parameter declarations. You may not have seen this already. So n has its type. which is the pointer to the node. And then words and pics are both of type pointer to int. So we have int with a little asterisk in front of it. That's an int pointer. And because we have two variables of the same type, we don't need to repeat the type. I can just put words, comma, pics, and then the type. And so words and pics are two variables of the same type. But I have 3 parameters overall, which is good because when I called this, I called it with 3 parameters. The top level node and the addresses of words and pics. Okay. Visit is going to call itself recursively on these nodes. So I have a node and the node has a child. We'll call visit on the child. Okay. And that's the way I did this way. So we're going to do some logic when we look at a node, and I'm going to skip that for 1 second because what I just said is the important part, and that is that once we've done looking at a node, we need to go visit the children. So we're going to need some sort of for loop because a given node can have many children. Okay, you may be familiar with different kinds of trees, like there's a binary tree where every node has 2 children. But there's no real restriction like that in HTML. So any given node could have several children, right? If I go back up here and look at my raw text, I have a body, and the body has a header, and then it has a couple of paragraphs and an image in the body. So it actually has several children. And we need to go through those children at this level. All right. And we do that by actually getting some pointers from the node. So the node has some actual things in it. I don't like the way it scrolls, but that's life, right? So when I look at a node, the node has a pointer to the first child, and each one also has a pointer to its sibling, right? So here in this loop, I'm going to get the first child of the node that I'm looking at. And my loop is it not nil? Because if it is nil, there aren't any children of the node that I'm processing in visit. And if it's not nil, then I'm going to have at least one child. And when I'm done doing that child, I'm going to ask the child, do you have a sibling? And if the child has a sibling and it's not nil, then we'll do it. So we'll go down 1 level and then we'll go over a couple. Okay? And for each of those, they may have children causing us to go down and go over. Right? So here I start at the top node, and if I look at my doc, right, the top node is in HTML, it'll have 1 child body. When I get to body, it's going to have siblings as its children. So the first child should be the H1, and then it should go looking at these other siblings in this loop. All right? The question will be exactly in what order, and I'll address that in just a second. All right? But for each child of the node that I'm processing in visit, so when I come into visit, I've got some node, it's got some number of children. For each child, in order, I'm going to visit them and just call myself again. So I'm going to call the same visit function, except now the node to be visited will be the child or one of the child's siblings. And again, we're still passing these pointers to words and pics. Right? So everybody in this tree is going to be, every time I call a node and visit in this tree, I'm going to be modifying the same words and pics. I'll just be adding to them. So that logic is good so far. So now I just want to say something about the order. When I visit a node, then I visit its child, and I have this loop that says I'm going to do the child and the siblings. Okay? But actually, this is depth first, because as soon as I get to the first child, if it has a first child, I'm going to do that child. So if I have this tree structure, I'm going down as far as I can, and then I'm going up and over and down and up and over and down. So it's a depth first tree traversal. All right, even though I've got this loop looking at children. We actually have to do the useful work. Right? And the useful work is to ask what kind right? What kind of tag do we have? Okay, so a node is going to have some sort of type, and that's represented by this another property of the node, which is type. And we're going to ask, for example, is it a text node? And if that's true, we're going to do something, okay? Because we want to count words, so we're going to go look at the text. But there's another case, okay? And the other case would be, all right, so we'll just leave a space in there to put something we haven't put in yet. So if it's a text node, we want to do one thing. And if it's not, we want to find out if it's an image node, and that's a little more complicated. Because that means it's an element, but also it's an element with a tag type of image. So if we go back here, right, we have the H1 heading and the P paragraphs, and then I have this guy, okay? It's not a text node, it's an element node, and its tag is image. And the tag is stored in the field n.data. And that's how we know that this is going to refer to an image. Now, in the case of image, the logic is going to be very simple. The typing is not simple, but the logic is simple, okay? In the case of an image, we're not going to ask anything else about like what kind of image. We just wanted to count them. So I'm going to increment pics, but I have to, again, it's a pointer, so I have to dereference the pointer with the asterisk. That gives me the actual pics variable that we created, right, which is this one. Down here in count words and images, I created an actual variable words. I've been passing around its pointer. So this pointer references back to that, pics, not words, okay? That pics with an asterisk is the pointer, and this is the one. And I could have made that maybe clearer. I could have called these P words and P pics. Maybe that would make it clearer for you. All right. If I call that P pics and I dereference it, then I get the original pics. Okay. I'm just going to do that. It makes it a little bit clearer. There's other things I could do. I don't often do it quite this way, but that's fine. What do I have to do if it's a text node? Well, I need to modify the original words. So I need to dereference P words, and we're going to add something to it. And the nice thing is, we already know what to add to it because we've done this before. We're going to call a strings function, right? Strings.fields. We did this in another example program. It takes the line of text and breaks it into words. What line of text? Well, again, in this case, the text of a text node is in the data field of that node. So I take n.data, all right, and n.data is going to be like this text right here, my first paragraph. Okay, we're going to break that into words, and then we're going to accumulate that number of words into the thing that P words points to, which is the original variable words. And again, so once we start this with count words and images, we pass in the pointer. Every call to visit is referencing the original words and pics and incrementing them as necessary. That, folks, is our program. Okay, that should be everything we need to run this program. And somehow, when I typed this, I eliminated the word length. Okay, yeah, I can't add a slice of strings to an integer, but I can calculate the length and now run it. And I get 14 words in one image, and that's what I expected. If I go back and look at this text up here, I could count all of this and I would find 14 words, and then of course there was the one image. And if I duplicate that, if I create another one of those and run it, now I should get 2. Okay, and you can make this more complicated. So step 1, if you're venturous, you could go figure out how to open a network socket and pull down like Amazon's front page and run this, and you'll get much bigger numbers. Okay, and you're also going to discover a little problem, and I'll leave this as an exercise. When you go down and pull a real web page, there are going to be some text nodes you don't want to count, and those are going to be the ones that have JavaScript in them. So you're going to need to add a little more logic in here that says, hey, it's a text node, but it's got JavaScript, and so don't count that. Just ignore that and any of its children. So you're actually going to want to skip those by returning out of here early. It's a text node, but it's really got JavaScript, therefore I don't care about this entire subtree. And I'll let you figure out how to do that. Because otherwise, you go to Amazon front page and you get this enormous number of words and you look at the page and you say, where are they? And they're not there. It's all the embedded JavaScript. Okay? So I'll leave that part as an exercise. So I just want to wrap this up very briefly from the top down. Right? Our main program, we took a raw string because I didn't want to go to the network. So we pretended that this piece right here is what I would have gotten back from the network. I would have gotten back a slice of bytes if I actually went out to a web page. All right. I put that into a reader. Now, if I were really going to a web page, I might have another variable of a kind I haven't described yet that would provide that function. But in the end, I need parse to take something it can read from, something that fulfills the need to be able to read bytes. And it will return a document and an error. Okay, we check the error always. And we pass that document, and what we're really doing, again, since the HTML document is a tree, what we're really doing is passing a pointer to the root node, which may have children. Okay, so we're going to run that, come up with some numbers and print them. Fine. So in order to do that, I'm going to have a recursive function. So I created sort of a first function to set up the variables, words and pics, and return them. And that way I can call visit with a node pointer and pointers to the numbers it's going to update, the accumulators for the number of words and the number of pics. And that way, when I get to visit, there's no special logic. Visit will do the exact same thing at every node. Okay, it'll look at the node, figure out whether it needs to count words or images, and then it will go and look at the children. Are there children? Go visit them until there aren't any more. And of course, if it goes into a child, that child may have children, and so it repeats over and over until it gets down to the point where I've got a root node. So if I look at this text, several of these nodes are going to be root nodes, and they're not going to have any children. And because they don't have any children, then this for loop doesn't do anything, and we just return back up, right? And that is how we do the sort of the ending the recursion. We get to a node that has no child, there's nothing left to visit, so this function, after checking the node, will just return back up, and we won't do infinite recursion. And we'll eventually return all the way back up to the root node, and the root node call to visit will stop and leave us with words and pics having the right values, and then we can print them out. Okay, so that's exercise 5.5, and again, I have the code for this on a GitHub repo that you can go look at that I pointed out to you.